Good morning, everybody. I hope you can hear me. Welcome to the University of Bristol's Faculty of Engineering Research Showcase. My name is Professor Ian Bond. I'm the Professor of Aerospace Materials here at the University of Bristol, as well as currently the Dean of the Faculty of Engineering. So welcome to the fifth of 8 live sessions where we are bringing together expert panels from across the faculty to discuss a key research theme. This session is dedicated to research from Bristol around advanced materials and manufacturing and what that means for the future. So I hope we have a very interesting, productive session coming forward. So we've got our panel of experts here across our materials and manufacturing groups, and I hope they're going to share with you very shortly some of their thoughts and ideas about research that's ongoing at Bristol, as well as their thoughts for the future, and how that will have an impact on industry in this very ever-changing environment we're currently in, and also talk about the importance of the academic and industrial relationship, which is key to that transition of knowledge. So materials manufacturing and indeed design form the triumvirate of activities that underpin the creation of artifacts within engineering. And as we face a future where sustainability, net zero, climate change are very much going to shape our futures, it's never been more important that the research into what, how and why we use resources to find engineering solutions to problems is absolutely at the forefront of activities. So we're currently seeing a rapid transition across many technological domains, with a move to renewable energies, electrification of propulsion and flying and driving, the digitalization and virtualization of everything we do, which is having an impact on our materials that we use, our approach to design, and indeed the means of manufacture. And I hope that's going to come through in the discussion shortly. So I will introduce the panel, first of all, just to give you an idea of what their backgrounds and what their interests are. So I'm going to start by introducing Professor Janice Barton. Janice.
Hello, everybody. I'm Janice Barton. I'm a professor of experimental mechanics, and my interests are primarily in using imaging techniques in mechanics to better understand material and structural performance. And I've actually been working in this area for the best part of 30 years. It doesn't seem like that, but it is actually true. My efforts are really focusing on at the moment this issue of sustainability and understanding better how materials perform and how we can introduce lightweighting strategies into structures, and in particular looking at how we use less composite materials. Over the years, I've introduced my sort of systems that I've designed into various different industries and focused the work on industrial problems. Right now, one of the other things that I'm doing is looking at new initiatives in doctoral education to look at better ways of technology transfer and embedding students within industry and working much more closely with industry, and looking at people who are coming into doctoral studies from non-traditional routes and having significant industrial experience as well as the necessary academic experience as well.
Thank you very much, Janice. Bruce, would you like to introduce yourself?
Hello there. Yes, I'm a professor of ultrasonic engineering in terms of my job title. So I work on all things ultrasonic, but whatever that means. But that's included over the years non-destructive testing, uses of ultrasonics, sensing and imaging, as well as more exotic uses of ultrasound, such as haptics and particle manipulation and levitation and things like that. So right across the technology readiness spectrum, I am the head of quite a large research group, well, large for NDT research groups anyway, with 5 members of academic staff and 30 odd students. I'm director of a Centre for Doctoral Training, which hopefully I'll be quizzed on later, which is a partnership of 6 universities and 50 companies. So we're recruiting and training 10 PhD or NGD students a year there. My own personal research, well, what's an interesting highlight? I guess, you know, I'm trying to push these NDT techniques to the very limits. So I'm particularly interested in if we can find new physical phenomena that allow us to detect new things. So, you know, one project I'm working on in nonlinear imaging, it doesn't really matter what it is, but it's got potential to discover or to measure the remaining life of a structure. And so that's something that really excites me, as well as pushing more traditional techniques like array imaging to find smaller defects and to characterize the defects more accurately. Yeah, that's me in a nutshell.
Thank you very much, Bruce. Ben.
Thank you very much, Ian. Well, good morning, everyone. I'm Professor Ben Hicks, Professor of Mechanical Engineering and Head of Engineering Systems and Design at Bristol. My research really focuses on creating tools, methods and technologies to improve how we design and manufacture things. And those things could be infrastructure, machines, products, or manufacturing systems. I guess in terms of my career, I worked on some of the first CAD systems. So constraint-based CAD systems, much of which are used in industry today, things like maths of surfaces, ACES solid modeling kernel, and similar. A lot of work on machine design, so kinematic and dynamic optimization methods for high-speed machinery and manufacturing production systems. And certainly, you know, going back 15 years or so, did a lot of work on sort of manufacturing systems, continuous improvement, production systems, and in particular on things like operational excellence, from lean thinking to design for changeover, and also a lot of work on systems engineering and design management. And I guess what excites me or I'm interested in are, you know, how we go about creating new or next generation tools and technologies that really support industry and ultimately enable you, industry, for many of you that are in industry, to do more, to do things better, and ultimately to do it with less. And that could be, you know, less materials, less resource, and less cost. So look forward to some of the questions. Thank you, Ian.
Thanks, Ben. And Ole.
Thank you very much, Ian, and good morning, everybody. So my name is Ole Thomsen, and my role at is as the NCC Chair of Composite Design and Manufacture, NCC being the National Composite Center. So I have a joint role. I'm 50% at the university as part of Bristol Composites Institute, which is in the Faculty of Engineering, and 50% at the National Composite Center. I'm the theme lead for the activity in Bristol Composites Institute on composites manufacturing and design. And I'm also the Deputy Director from the EPSRC Future Composites Manufacturing Research Hub, which is a large government-funded activity or research activity embracing 16 universities in the UK currently and about 40 companies, aiming to basically promote a step change in composites manufacturing of composite materials for all sorts of applications. My background is, well, as Janice said, 30 years. Mine is probably 30 years plus in composite materials. And my focus has been, at least in the early days, design and validation and testing of lightweight composite structures across various applications. You could probably hear from my accent that I was not born in this country. I'm Danish, and part of my heritage there is I worked for 20 years plus with development of wind turbine blades together with industry over there. So renewables, of course, is something that's very close to my heart. But here we work across sectors, and aerospace, automotive, and evolving sectors is a significant part of that. My role as the NCC chair is really to develop and promote the transitional research area where how do we bring research from the fundamental research elements that we typically do at academic level at universities into the application space with companies, and how do we make that attractive for both academia and industry to do this, and how do we select the products and the technologies that we want to promote. So that's in a nutshell is what I'm doing. I'm trying to do the best I can. I look forward to any questions you may have on that.
Thank you very much, panel members. So we're going to start by asking the panel a series of questions that we've come up, which hopefully help articulate some of the things that they've already mentioned in their introductions. And then we'll open to a general audience Q&A. So if I could remind you to please use the Q&A tab at the bottom of your screen to add your questions. And then we'll do our best later in the session to come back and give a good opportunity to answer some of those questions. So if I may, I'm going to start with some sort of fairly general questions, picking up on the themes we've already mentioned around sustainability and digital engineering. So really, I'd just like each panel member, perhaps starting with Janice first, is what sustainability means in terms of your research and how you think it's addressing that challenge that we're all facing.
Thanks, Ian. Well, it's really in order to make our infrastructure and vehicles and so on more sustainable, it's really important to understand material usage and understanding when factors of safety and so on are employed that are far too conservative. Also to understand how hidden defects within materials introduce structural knockdown and so on. So developing techniques that can understand and provide information on how material is used in areas that is not necessary, and how defects actually affect structure through their life is very important. So from my particular perspective, one of the things that I'm working on now is a proposal about understanding composite material behaviour from the cradle to the grave. So we worked on developing some sensors that can actually feel the through thickness strains in the composite material, and this is where it's inherently weak. So those are the kind of things that I do that I think really help sustainability. And then thinking on to how you actually repair structures and how you're able to reuse structures that are difficult to dispose, because composite structures are made from generally thermosetting resins, which are difficult to get rid of. So actually being able to reuse that or extend the life of large composite assets through having better repair methodologies and so on, and developing sensors that tell us how that repair is performing. So that's kind of where I think I'm making my contribution to the sustainability agenda.
Thank you, Janice. Bruce, where do you think?
Well, yeah, Janice has outlined that the ground quite very nicely there, and I guess I fit in between those two bits. When we're thinking about trying to sense the current state of a structure to as best and as accurately as we can say what its health is and whether it's fit to operate. I think increasingly that if you go back some years, those sensor systems would be very much deployable. So a group of engineers would go and make some measurements on a structure, but increasingly they're becoming embedded and becoming an integral part of the structure. So these concepts that were talked about many years ago, smart structures, I know you worked on them, Ian, they're now maybe not quite in the way it was envisaged then, but they're becoming a reality. It's still at the stage where things are fairly bulky things are attached to structures, but the direction of travel is a kind of a seamless integration of the sensors and the systems. And we have in the group led by Anthony Croxford and Paul Wilcox, a spin-out company, InductorSense, to market a particular sort of sensor where the sensor's embedded on the structure and all the electronics are in a separate box, and that's electromagnetically coupled to the sensors. So it means that the thing that you attach to the structure can be super simple. And that's just an example of the sort of things that we work on. But yeah, that's kind of, so why that's important. I think Janice explained why that's important. But if you can continue to monitor the structure, then you can target your maintenance and repair to best effect. So I think that's all part of the sustainability argument.
Thank you, Ben.
Thank you very much. Yeah, and it will come as no surprise to those listening, being part of the systems group. There are two aspects to sustainability and really delivering a fundamental change. One is taking a systems level approach. So you want to bring about that fundamental long-term change. So we have some work, that's taking very much of a systems view, but we also have to be pragmatic, as lots of colleagues have alluded to. So you have to look at the current sort of tools, systems and processes and work within those to try and be as sustainable as possible. So we have two examples of ongoing work. We have a current project we're developing and working with Sheffield AMRC on, looking at how do we ensure that the processes, the digital engineering processes that are being used actually deliver the right information at the right time and in the right amount to positively influence decisions around sustainability. So, the obvious one there is, what is the current practice and how are engineering teams using the capability within their tools, methods and processes, and trying to maximize that in terms of sustainability. The second one, which is very much more about taking a systems perspective, is we're working with the Southwest Infrastructure Partnership to start to look at how can we decarbonize the whole region, the Southwest. What does that look like? And a particular interest there and bringing our expertise is around what we call the transition pathways. How do we transition from where we are to where we want to be, and what do those steps or pathways look like, and how do they change over time? And a final example, which I suppose illustrates the collaboration within the faculty. We're all very collegiate, very collaborative. We have a project which has just been submitted with colleagues from the Bristol Composites Institute, which is looking at how do we take waste, two common forms of waste, so plastic bottles and cardboard, so cellulose materials. How can we take those and actually use those and repurpose them and create functional artifacts? So using a combination of 3D printing and, I say, novel, processes for recycling and potential treatments or regimes which don't need the sort of a small chemical factory alongside. So the ultimate goal there is to be able to repurpose, reuse waste within the local economy to meet local needs of communities, to have a sort of circular recycling, remanufacturing and reuse capability. Thank you, Ian.
Thank you, Ben. Ole.
Thank you, Ian. Yes, so to supplement my colleagues, so sustainability in my world is really embracing a very large area, many different aspects of this that we all need to address and attack in various ways. So just to get started on this, of course, one of the elements of that is the use of inherently sustainable materials. For instance, bio-based materials. So can we use those for the types of structures and products where long-term durability and other constraints are very important design factors? We are doing a lot of work of that in that area together with the NCC and across the faculties. Another way of addressing this, which is in a parallel track, you could say, and integrated with this, is can we use the materials that we're currently using in a more efficient way? This includes can we manufacture them in a more cost-efficient and sustainable way? So reducing energy usage in manufacturing processes, develop manufacturing processes where we reduce waste, ideally zero waste and defect-free as part of it as well. And a third branch of the attack on this is research and activities aiming to basically achieve more efficient structures or performance of structures. So for instance, as an example, we now pretty much all realize that the way we're currently conducting civil aviation probably can't continue. The use of kerosene as a fuel for the propulsion systems is creating lots of emissions, and it looks like we need to come up with something different than that. It could be electric propulsion hybrid, or it could be something with fuel cells or hydrogen. But in order to go there, we also know already now that the way we design aircraft structures right now simply will never be able to deliver those weight reductions needed to do that. So we are working at the same time to be able to use the materials more efficiently, reduce weight, enhance performance, So we're radically changing the way we design and validate, say, various types of structures and products, aiming to basically, for instance, the key thing here is weight. Can we reduce the weight? And it could be that the target weight reductions would be like 30, 40, 50%, and which are unachievable with current practices. So this is another strand of research. Overarching everything, of course, is how do we develop this circular economy? We need to think about not just the creation of the product with the raw materials and so on, but actually its life cycle, energy use in that, the embodied energy, of course, in the produced product, its life cycle, and also end of life, so decommissioning. And recycling, of course, is a large part of that as well. So recycling, can we reclaim the materials used in the structures or the products and feed them back into the supply chain and make new products of that? Those are a number of the challenges, all of which at different levels we are working with in close collaboration across the faculty, with other colleagues at universities, with other universities, with colleagues across the globe, and with industry in the UK and internationally as well. So it's a massive challenge we're all looking into, and I think probably sustainability is one of the big overriding things that we really are into. Thank you. Thanks,
Ole. So perhaps another big thematic area that's sort of come across recently, this concept of the digital impact that digitalization is generally having on engineering. And I'm just interested to know from each of you where you see that having a major impact, but also how it's helping or providing new insights. So the fact that now we can virtually design digitally from the atomic level up, and the ability to simulate virtually entire systems, so the scale goes from the atomic to the full, global scale. How do you think that digital capability is impacting in terms of the sort of materials and manufacturing world? So again, Janice, over to you.
Okay, all right. So, I mean, when I started off 30 years ago in the world of imaging, to try and collect the data that I used, that I needed, took hours, okay? And the likelihood of introducing damage in a structure in the time that it took to collect the data was high. So the digital revolution has really done massive things for my research area, in the sense that, first of all, we can capture images in a matter of fractions of seconds now that we can use. We can look at real-time responses and so on of structures under structural test, and also allow us to go out into into the field and actually measure things we couldn't measure before on real structures. So that's a massive impact. And of course, along with that is combining that experimental data that you've collected into adaptive models of systems and so on. So, the buzzword at the moment is digital twin, but this is something that we've been working on for many years. How do you bring your experimental data together with your model data to better understand a structural response? And of course, the massive advances in computing power and so on has really helped that. But the real benefits of this are yet to be reaped, because we can test things much more efficiently at real scales, and that's particularly important in composite materials, where there are scale effects, where simple coupon tests don't tell us everything about how the material's going to behave. And features that are embedded into a material as part of the design in order to make the shape actually have a large effect on the structural performance. And being able to test that and combine that with models and update models and use the models to actually predict what's going on. So the world of virtual testing is with us now. And I think, although my background is in experiments, I think in the future there will be fewer and fewer expensive experiments, because we'll be able to do so much more in the model space.
Thanks, Janice. Bruce, I'm interested to hear what your thoughts are.
Yeah, well, I mean, a lot of that is exactly true in the kind of field of non-destructive testing. I think as well, one of my own interests on array imaging. The data was historically a big issue. Each measurement is a couple of megabytes of data, and you want to scan this sensor rapidly over a large structure, so the data is huge. But that's not really the problem that it once was. So the kind of data and computational power revolution has enabled things that just weren't possible before, and that's had a big influence on sensing and imaging and non-destructive testing. I mean, one thing that's I guess particularly relevant is some work we're doing trying to characterize defects, and we actually do this kind of very much like how you do a Google search now. Is we run a whole load of models and we form this database, which is like all the stored results somewhere in the cloud, I guess, eventually. And then you make your measurement on your structure, and then you search amongst this database to find an entry in that database that's as closely matched to your measurement as possible. And you then say, well, that's a good chance. Of course, it has to be embedded in a proper statistical framework, but you then say there's a good chance that measurement corresponds to that previously computed entry in the database. But what Janice mentioned there is really critical there. Your database has to be good. These things are only as good as the database, and of course the searching has to be fast. But that's actually the thing that now is a given. But the sort of two bits that require a lot of kind of effort from people like me are getting the database right. So that's on the modeling side, producing good models that are fast and accurate, so you can compute this database. Because it's inconceivable to form this database experimentally, so it has to be done computationally. And then the other part is to understand really well the physics, so you make the right measurement in the first place, because you can waste a lot of effort by making the wrong measurement, and then you kind of have no chance. So this is kind of an active area, and we've shown that these things are possible kind of in the research lab. So that work is an example of something I would expect over the next, I wouldn't like to say how long, 5 to 10 years, getting out into industry and seeing that being used. So that's quite an exciting part of the cycle for me. And of course, I'm always hopeful that it always happens that computational power will improve, and so all these things will be even easier than they are now, which is kind of a good feature.
Thank you very much, Bruce. Ben.
Thank you very much. And I guess to build on what colleagues have said, it's just a little slight digression. Was when I started out, prior to joining academia, I worked for a while, a number of years as a consultant. And at the time, if you looked at what we did, we'd worked with the aerospace and automotive sector, and a lot of it was developing simulation-based approaches, because high non-recurring costs had to be right first time because of those reasons, but safety critical. By complete contrast, if you worked in the pharma industry, a lot of the special purpose machinery manufacturers would have 12 weeks to turn around a new design. They could do that much faster by building it, testing it, and commissioning it on site. So there was always a cost benefit question is where I'm going with that. And colleagues have talked about digital twins, but I think I've seen as this sort of the coming together of digital engineering technology. And with regard to digital twins, we are doing a lot right across the faculty, looking at digital twins for production systems. So how do we increase automation and intelligence and drive continuous improvement? We're also looking at digital twins of products in service to understand what information, understandings and insights can be generated to improve the design and redesign. We're also looking at a program looking at digital twins of infrastructure, so things like Clifton Suspension Bridge, ultimately to optimize the performance and value of infrastructure to the end user, but to increase remaining useful life and things like that. And in all of that work, this cost benefit is always something we're looking at to say, well, actually, what is the invested effort in, for example, creating and maintaining a digital twin, and what's the value to industry, to the organizations? And in that regard, we're working closely with colleagues in the School of Management to actually understand how this transition from legacy to Industry 4.0 can be enacted. Again, what that pathway looks like. How do you change what technology, tools, people, skills, and business processes? And again, aligned closely with that is the university and faculty are heavily involved in the Digital Engineering Technology and Innovation Centre, which is led by the NCC, so the DETI programme, which again is looking in the region to say, what are the enabling tools and technologies, and what are the skills gaps? What are the training requirements? How do we take the operators? How do we take the engineers and designers? How do we take the business and the business leaders through that transition to digital engineering? What does it mean? What are the benefits? And how do they undertake that sort of transformation? So there are, the technology has matured, as colleagues have highlighted, and is continuing to advance. We have unprecedented capability in terms of modeling, in terms of compute power, in terms of bandwidth, in terms of data collection and how we can process that. But actually, how do we use that to, again, do more, do better, and do it with less for industry? And how do we support industry going from where they are today to where they need to be to deliver on these challenges like net zero, such as those raised by Ole, etc. How do we support you in that journey? And not just in terms of technology, but in terms of the socio-technical system, the people, the skills, and the organisation as well. Thank you, Ian.
Thanks, Ben. We will come back to skills momentarily, but yeah, that's a really interesting response. Ole.
Yes, thank you. Just very hopefully briefly and supplementing my colleagues with a few additional points. So picking up from Ben, if I could focus a little bit on my own research focus right now, which is very much about, say, the validation of performance of safety critical structures. So if we look at how that is done, for instance, for composite materials, that's very highly based on testing and the so-called testing pyramid with lots and lots of tests at the bottom of the pyramid on coupon level, very small elements, and then a number of tests and higher length scale, ending up with a full structure test, for instance. Other sectors are using the same methodology. So the structures, the products we're having out there are basically validated safety-wise based on a very expensive and time-consuming say testing approach. This really simply is not feasible as we look ahead because of the cost and time involved in this. Is prohibitive for some types of products to go down that route, and it actually does not necessarily provide the safety we want, and more importantly, it doesn't really allow us to understand the full performance envelope of the product we're looking at. So the digital technologies, and here it's virtual testing. So there's the step from physically based testing to a world where we now increasingly are basing our analysis and our assessments on model predictions on different length scales, allow us then to basically predict the performance, behavior and performance of the material in situ on large scale in the structures in a much more accurate way. And one of the key things that we can do in this is that we can take into account the inherent variability, for instance, in manufacturing processes, which influences the end product, the end material in significant way. And this is very true for some of the new emerging technologies, additive manufacturing. There's no such thing as a standardized additive manufactured material. So really, to understand what the product performance will be, we need to understand and have track on how it was manufactured. And this is what, among the things we can do in the digital space. So what we achieve with this is cost reductions, reduction in time, so development time, higher reliability of the final product, and actually a much better understanding of the performance envelope. What can we actually do with this before it exceeds the envelope? So intrinsically, we aim to make something that it has to be inherently safe. Safety critical structures have to comply with regulations on this. We have them in aerospace, we have them in other sectors as well. And a way to do this in a much more efficient way is to step into this digital world, the virtual testing and the digital twinning.
Thank you, Ole. So just sort of changing gears slightly, as I said, we will come back to talk about skills, but I think there's perhaps another interesting area. So we've talked about sustainability, we've talked about digital engineering. I want to touch on knowledge transfer and how all the great things we do, how do we get that out there So I'm interested to hear from the panel in terms of what their experience has been and how they've seen good practice in terms of transferring knowledge from the bench effectively to practice. Janice.
Okay, so there have been lots of good things happening recently at the University of Bristol in sort of transferring our knowledge in composites manufacturing through our industrial doctoral centre in composites manufacturing, and the difference between the industrial doctorate centre and the CDTs that we have in Bristol is that the students are embedded in the industry from day one. So they're developing with the company the research ideas, and then using the resources from the university to sort of take for the technology transfer. So that's been a really major achievement. And I can see one of the questions in the Q&A was about, how will doctoral training change in the next 10 years? Well, I think that we have to move closer to industry. There needs to be more of an industry pull and in our research, and the way to do that is to embed our doctoral students within industry, tackling the problems that are important to industry. That doesn't mean that there isn't a place for fundamental, more basic research, but I think we need to have a much more blended approach to our doctoral training.
Thank you, Janice. Bruce.
I mean, the challenge that you're talking about is the often talked about valley of death, isn't it? That universities generate a lot of ideas, and how do we get them across the valley of death? And the valley of death is why does it exist? I'm not sure I know the answer to that, but definitely one of the reasons is funding. That there's a lot of funding for fundamental work, and then within companies there's internal money for development, but there is a bit of a gap. Things like Innovate UK attempt to plug that gap, but it's nowhere near sufficient to easily bridge the valley of death. But I guess as a practical kind of example, I'm part of a research centre called the Research Centre in Non-Destructive Evaluation, RCNDE, which is a kind of a way in which you can potentially get over this valley of death. So it's a research centre that's like a lot of them, I guess, but a collaboration between UKRI funding and industry funding. And so we use obviously the UKRI funding is earmarked for the low TRL technology readiness level scale, fundamental ideas and development up to kind of prototype level. But we use the industry funding to fund technology transfer projects to exactly address this. So funding is one bit, but the other key bit is an open forum for discussion as well, because technology transfer can't really happen without both the university industry partners discussing things. And so that's the other bit about knowledge exchange. And we exactly do, because we have a centre for doctoral training as well in this topic, and we see particularly the Eng.D students who are embedded in this industry typically for 3 of their 4 years as a really good vehicle for technology transfer for bridging this valley of death. So well, there's a few things that you can do, but it's a recognised problem across across the world basically. I don't think there are any short answers to it, apart from a big load of money from the government, but that's unlikely to be forthcoming.
Thanks, Bruce. Ben.
So thank you very much, guys. Yeah, it's Pandora's box a little bit, isn't it? But I think I'll just highlight that there's two aspects perhaps. One is around impact and knowledge transfer of perhaps, I never like best practice, but good practice. And perhaps some of the for example, things like QFD, design for manufacturing assembly, lean thinking, were researched 15, 20 years ago, were quite mature. And we find we do within the group quite a bit of knowledge transfer, if you want, and gain quite a bit of impact through application and advising on those sorts of tool sets. And that's not consultancy, but that's more knowledge transfer. So an example of that is a recent one. We've been working with the Royal Academy of Engineering during this pandemic to bring to bear our skills, our tools, and our capabilities within the faculty, particularly, but broaden that across a number of universities, both nationally and internationally, to actually create a toolkit to help globally help individuals, organisations transition out of lockdown. So low-cost items such as social distance glasses or non-contact customer counters, or very low-cost ventilators and open source, etc. So that's through that mechanism of making those open source and the funding from Royal Academy of Engineering, we've had quite significant reach beyond just the UK. But again, a lot of that isn't about cutting-edge research; it's about the skills, capabilities, and expertise within the institution and the faculty. Second aspect is if you look at the fundamental research, I always think ultimately it comes down to both organisations providing the resource and working together in more of a partnership, and accepting that it will take a bit of time, because there's a lot happening at the university. Organisations have a lot of a long wish list, and it takes a bit of time to if you want to work together to identify where the quick wins are, where the longer term wins are, and then how you invest in those and support those. Two very quick examples, I'm conscious of time, is we're a global lighthouse for Autodesk, so we work very closely with Autodesk, working on the evaluating and trialing new technologies, such as their generative design suite. So we launched with, I think, globally, the first undergraduate course on generative design, which ran this year. It was very well received, obviously working closely with Autodesk and training our students to use those cutting edge technologies. We also have a joint role with the Centre for Modelling and Simulation, CFMS, which is a joint 50-50 split role, not dissimilar to Ole's, working with CFMS and the University of Bristol to really support the region. And that's investment from the faculty and investment from CFMS for 5 years to develop joint capability. So these things do take investment, but they also take time and individuals to identify almost a portfolio of activities and wins for both organisations. Thank you, Ian. Sorry, a little lengthier than intended.
Sorry, no, thank you, Ole.
Yes, so supplementing the many wise thoughts from my colleagues. The transition of research, if we call it that, of course, requires a dialogue, a communication between the researchers doing the fundamental research and the takers of it, the industry or the technology development organizations or the RTOs. And we are having such a very close collaboration and relationship with the National Composite Center, but there are also similar things with other of the so-called high-value manufacturing catapults. And all the NHD program, so the industrial doctorates, has already been mentioned as an excellent way of generating this conversation and this dialogue, and actually this ability to use facilities and know-how from university and bring it into industrial development. But there are other examples, other ways of doing it as well. And just as an example, the way we work together with the National Composite Center, where the National Composite Center has a number of so-called core members, tier 1 members, which are buying into the expertise of the NCC and contributing to having, say, research programs developed up there. So faculty members from the Faculty of Engineering or from the university as such are involved in these programs, can basically add to them by say their understanding of technology and do that, and this generate conversations, new ideas for projects that basically benefit both sides. So the university benefits immensely from understanding actually what's relevant, what drives the technology on the industry side, and the industry, of course, then gets the other side. What are the more fundamental research aspects of this, and how do we bring them together? It's very crucial part of this is to identify which technologies, what part of the research is inherently relevant for industry uptake. And as a specific example of how this can be done, the NCC has got this so-called technology pull-through program, but basically it's a screening of ongoing research, and some projects can come through to that. And then there'll be a funding opportunity and a project constructed around how could we take this research that maybe sits at TRL 2 or 3 from the university side, but needs to be to go forward for commercialization or upscaling. How can we do that? And that kind of greenhouse of the ideas and the technology happens there. We have a number of examples where fundamental research, initially funded by EPSRC on, for instance, how do we reclaim carbon fibers and make a usable product out that could even go into, say structural composites. It's a product called HybridIF, or a process called HybridIF. It takes carbon fibers, recycles it, and make it available. This has gone into a technology pull-through process where it's upscaled and basically developing the manufacturing facility to do this in much larger volumes, which can then be brought into as a recycled back into industry. And this is takes time, that's mentioned already. It's not something that's very quickly, but it takes time. But this kind of process where we need to have the forum where academics, university, and industry people can talk together and develop, exchange ideas, because it's not a one-way stream. It doesn't go from university to industry alone. It also goes from industry back to university. So it's really a cyclic thing.
Thank you, Ole. I just want to cover one last topic before we go to Q&A, and I'd appreciate if we keep the responses reasonably brief if we can. But questions around skills. So often, I know this is really about the research, but a key part of that knowledge transfer is also the people we develop and send out there as part of that research activity. So I'm interested to hear from the panel in terms of, is there something better we could and should be doing around skills development so that the graduates we produce, whether they're undergraduate, postgraduate, whatever, and indeed the researchers we employ, that many of which then go on to work outside the organisation, is there something we should do? Do we equip them well? Are there ideas that we could perhaps bring forward? The breadth of what we cover when we teach. What is a future engineer? What do they need to have? What skills are they expected to have? So thoughts from the panel in relation to their own areas.
Okay, so I'm going to answer your question. You're going to have to forgive me in a roundabout way. I think there's a fundamental problem emerging in doctoral training, and that is the pool of candidates that are becoming available to us. And largely, there's a threat because of the situation with Brexit, because now we find that students from the EU need a visa to come and study postgraduate in the UK, and they also have to pay rather a large sum of money for the visa and for the NHS access that they might require while they're here. So this is actually going to reduce the pool of potential talent that is available to us to take on at PhD and doctoral level. So we need to look elsewhere. And this is why I'm working very hard in this area called doctoral mobility, where we look at our existing talent pool that is in industry, people who didn't do a PhD or do doctoral studies at the end of their undergraduate degree course, but actually have the capability and the skills, and now are in industry and actually find it difficult to move from industry back into education. And I'm exploring ways with a number of industry partners, but in particular the high value manufacturing catapults and MPL, as to ways that we can actually bring people back in to doctoral studies to get the skills that UK industry will need in the future. We need to be a much more, with the one thing the pandemic has shown us, we need to be much more agile and much more resilient, and creating much more flexible ways of learning is the way forward. Now, how does that impact on my research? And I think this goes back to some of the things that have been said earlier about, lots of good ideas die in that valley of death. If industry is integrated into our doctoral training programs in a way that they are supplying people and paying them maybe not their full salary, but part of their salary to do doctoral training, then more of these good ideas will transfer across that bridge and this so-called valley of death. So I think this is something that is absolutely current, and I think we as universities need to be the driving force behind changing some of the way that we do things to allow this mobility to start, and also looking at industry to strongly support that as well, not just the research councils.
Thank you very much, Janice. Very heartfelt response. Bruce.
Yeah, I mean, it's a really important question. I guess I can really only answer it coherently in like Janice on the doctoral training side, where I'm director of a CDT, and so I know the process we went through to design that training was one of, well, the buzzword is co-creation, but really that just means working closely with our partners, who are mostly industry, in making sure the training meets their needs, because our raison d'etre really is to train people that can then go into industry and progress up to high level jobs. And so what that ultimately means is that industry has had a hand in creating every aspect of the taught element. I mean, obviously the research element is a slightly separate issue. Those are also linked to industry, but on the taught elements that you have within the Centre for Doctoral Training, that means we get industrial lecturers in on the technical modules, but it means we also cover transferable skills, and that means things like entrepreneurship, and also we try to give the students hands-on experience as to what goes on in the various different aspects of non-destructive testing within industry. And the only way we can do that is with industry helping us to do that. So yeah, we've had to work, and it's been hard. The COVID situation has not exactly helped some of these activities, because they've all had to be online, and these sort of things don't work as we like. A lot of us, we've done our best in difficult times, but they work best when the students can actually move about and go and visit and properly interact with all sorts of groups, including industry. I mean, yeah, that's probably, I'll stop there for brevity reasons. I could say more though.
Thanks, Bruce. Ben.
Okay, I'll try and speak quickly as well. I'm conscious of time. We've got questions. I think there's two aspects which often get confused. One's education and one's training. And I think what colleagues are saying, that the CDTs have been highlighted as a great mechanism or vehicle that does bridge the gap a little bit, provides a training environment for specific skills for industry to meet the current capability. Where I'm going with that education and training thing is I'll leave it to the audience to go and look at the research that's out there and the data on the difference in terms of investment made by industry in training in the US, Germany versus the UK. And there's a stark contrast. Again, what I'm in no way trying to imply there is that that's a problem for industry. Actually, it's for both, for universities and those educators and industry to work together. Training is continuous through life. It's a lifelong journey, as colleagues would say, for all of us. And actually, we do a lot in our degree program to provide those lifelong learning skills and equip in terms of the fundamentals. But the program is very, very full. And professional institutions, etc. We work with industry and professional institutions to maintain, create and maintain the currency of those programs. But I think we can do more around, as I said, continuous training and development for all, both for us as academics, but also for those in industry. And I said things like the DETI partnership in this region is looking to create new mechanisms to really address those shortfalls. And I think the message I'd say to industry is the responsibility is shared between us, the academia and industry, to look at what the training requirements and skills requirements are, and then how we creatively create mechanisms both in this region and nationally and internationally to deliver on those requirements. Thank you, Ian.
Thanks, Ben. Ole.
Well, I'll try to be brief as well, and picking up from Ben, and maybe going back a little bit more fundamentally to what is training and what is education. So one perception that's probably old-fashioned and probably not relevant anymore is the idea that you do a degree program, and then you leave university with your diploma, and then you have all the skills you need, and you're ready to work there. So it's, obviously that's not going to work. We know that we have an ever evolving world with new challenges evolving all the time, and it seems to be the pace of increasing speed. And it's probably not going to be sensible for any of us to try to predict what is really necessary, what's needed for us in 10 years' time. What do our graduates need in 10 years' time? I don't have a clue. I'll have to say, to be humble on that. So what can we do at university? The best thing we can do to prepare graduates and people skills for the future. Well, I think at university we should teach them what they can't easily teach themselves or find anywhere else. There are some basic boundary conditions to our existence that probably are to some extent governed by the laws of physics when we're in engineering, for instance, in my own field. Then we need to develop a culture, a mental mindset of ever learning, increase. So it's never over. It's a constant, continuous journey through life that we'll have to learn and adapt to the world we're in and how it evolves. And that part of it I think is a central thing in our minds about how do we see an educational program, the training piece. So we should basically strive to give people skills to learn as they go along in life. And the CPD activities we're talking about, the dialogues across the stakeholders in this, from universities, industry, and so on, all that goes into this mix of what is needed. And of course, it's a completely different world than it was to be an engineer 50 years ago, probably because the pace of change is so radically different now.
Thanks, Ole, and thank you to the panel. Really sort of insightful answers to the sort of 4 A's. I'd like to now move to questions from the audience. We've got a couple that have come in, so rather than go around the 4, I'm going to ask you to volunteer to answer if that's okay. I guess the first question we've got here is a little bit touching on the kind of knowledge transfer, the impact. So lots of excellent research underway at Bristol. The pace of transition into industry needs to increase. I think that was the message coming from this question here. How do the panel think that might be achieved? What needs to be done to increase the rate at which knowledge transfer takes place? Any volunteers to pick that one? Ben.
I'll go for it. Thank you very much, Mark. I can see that there's a few questions there, and if Ian will permit me, I'll try to be brief but touch on 3 of your questions, Mark, so that other members of the audience can think of their questions. Your first part, you asked about the sustainability across the Southwest. All regions are distinct, and Bristol, I don't want to say we're leading on it. We're heavily involved, pardon me, in the regional activity through the Southwest Infrastructure Partnership and all of GW4 plus Plymouth and other institutions. The second point there is really about the transition, and in a couple of your questions, you've really alluded to the fact it's not just about technology. It's about, it's socio-technical systems with people and technology and processes, etc. And certainly one of the ways we can accelerate that is closer collaboration. And for engineering, which we're blessed at Bristol to have world-leading engineering with a world-leading business school now, actually how do we, and we do have quite a number of projects in that space, starting to look at the things like technology adoption. How do we accelerate the adoption of these new technologies? How do we increase the rate at which we transfer? And again, those take, that have to be co-created to understand what are the barriers for industry and how do we accelerate that rate of adoption within those organizations. You also asked about our degree programs, and the answer is yes, we are always improving our degree programs to incorporate some of those aspects, and particularly the systems, the sort of business entrepreneurship. So we have modules, particularly in the 3rd and 4th year, that students can do on sustainable systems. Our professional practice modules cover quite a few of the aspects that we've highlighted today. We also introduced an advanced topics unit, which has 16 short topics, which covers, again, state of the art in terms of NDT, in terms of systems thinking, in terms of things like generative design. So we are looking, ensuring that these concepts and emerging and developing tools and thinking are incorporated into our programs. Thank you, Ian.
Thanks, Ben. Bruce, who'd like to come back?
Well, I think Ben's reiterated what I think is a critical point about working together. But one thing that I've increasingly come to think is important, and that's making sure we train our doctoral students to think about technology transfer. So that was the idea behind on our CDT, teaching them entrepreneurial skills, because they, at the end of the day, are doing a lot of the research day in, day out. And one of the issues is that as academics, we are prone to explore kind of interesting dead ends. And if we, which it can be a really, really good thing, and those dead ends, of course, can be the laser or something like that. But equally, I think it is helpful in the round for our students to be thinking about the technology transfer right from the beginning. So I guess my thing we can do is to try and train our students to do that, and to try and think about technology transfers early in the process as we possibly and conceivably can.
Thanks, Bruce. Janice?
I managed to unmute. Yeah, I think also it's not just our doctoral students, is it? It's actually, you know, our main product are our undergraduate students, because they go out into industry. And this year in mechanical engineering at Bristol, we have created a new initiative with our undergraduate students, predicated largely because of of COVID and so on, where we've introduced a new unit where members of staff have created a programme of lectures lasting over a 5-week period on their specialist topics in research. And actually embedded into that is the relevance of our research to industry. And this is what students are really interested in. And our students have responded very positively to this. And I think we need more of that. We need more connection between our main product, our undergraduates that go out, our main ambassadors, so they can see how our research connects to industry, to actually bring back the connections once they're within industry as well. So I think that's a very positive thing that's come out of the negative situation of COVID.
Thanks, Janice. Ole, did you want to?
Well, I can just supplement. So I think I already touched upon this topic a little bit in previously to today, but I think a key thing is to create the environment where university people, whether it be PhD students, postdocs, senior academics, or even undergraduate students, can be in contact with, exchange ideas, views with takers, industry, RTOs or industry as such. We have some of those mechanisms developing with the NCC, and having, for instance, the technology pull-through program as an excellent example of how this can be done. It's not the only way. This is not just one solution that one shoe fits all, or one size fits all. There are many ways of doing this, but I think the crucial thing is the ability to have the communications so that the work done and the interest on the other side, the pull, so to speak, is known across the board. If we don't have the communication, we don't talk, it's not going to happen by itself. So we need to create proactively those fora where those conversations can happen. And that's a very broad answer, but I think that that's really what we need to do. And then there will be various mechanisms we can put in place, funding streams, short burn funding streams to try out, proof of concept ideas, quick, fast, without too much bureaucracy, and see what works, what doesn't work. But this is key to success in this.
Yeah, thank you very much, Ole. A question just coming in, quite specific question around, I think we touched on the CPD, so the training, so it's training in composite skills particularly, and if you're not a member of the NCC, what provision of training would we be able to offer? So I guess it's a question around, do we have ambitions to provide CPD in our specialist areas, particularly in composites, this question is referring to, but as part of that skills agenda, should we be doing more to provide those opportunities for industrial partners to access the training and skills that we could potentially deliver? Janice?
Yeah, that's it's a very relevant question, because it's something certainly in the composites area and the overall design and manufacturing area that we're looking at with partners in NCC, AMRC, Warwick Manufacturing Group, and MPL, how we actually create and use the units that we provide, the taught units that we provide in our MSc and our doctoral training programs, how we can actually use those for CPD as well. And once again, I'm sorry to sound like a broken record, the pandemic has sort of provided us with some opportunities, because now we're very much into this blended learning and online learning, so people don't have to travel for miles to actually engage in this kind of training, and so we're really closely looking at this. But one of the main issues is how well prepared are people to take these CPD units. So one might think, well, if people are prepared to pay for it, then obviously they're going to be prepared. But one of the things that we've been talking about is actually how we can introduce a bridging the gap unit for people who haven't been in education for many years. So how we can do that, and a sort of self-assessment as to whether people are ready to take on this CPD, which is the other side of the coin, making sure that it's really going to be useful for the people that are engaging in it at the level that they're at, because nothing could be worse for the universities than someone coming along, engaging on our courses and saying, well, that wasn't really much use to me, it was all way over my head. So we have to prepare for that situation as well, and we're working really hard on that. So thanks James McArdle for that question.
Thank you, Janice. I'm conscious time is ticking by, and I'm not seeing any more questions at the moment. Are there any final points the panel would like to make before we close the session?
Only really to say to the audience, you know, when you look at working with the university, and colleagues have touched on a number of things, particularly to Janice's comments around what's our output, what's our core product. Think about there's 4 value streams really for you. One is a talent pipeline recruitment. The second one's in no particular priority, by the way, here. The second one is around education and training. The third one's around knowledge transfer and consultancy, so accessing our expertise. Many of us have had, you know, quite lengthy careers in industry where we were applying these tool sets. And it might be something like lean thinking that we're no longer necessarily researching actively, but we still have a lot of expertise that we can offer. And then the fourth one is about the research. And when you look at this, don't think of it as a single sort of transaction, but think of it as a portfolio that you're going to grow and shrink with us over time. And then the final point would be that universities are like a large group of companies, or a vibrant marketplace. There's an awful lot going on. So it will take you some time to find that sweet spot with us. What's that first project, or what's the next project? It will take time, both, you know, on our behalf and on your behalf, to really identify what the project looks like. There are lots of established mechanisms, but the message from some of the early responses are that we can try and be creative. We've got the Dean of Engineering here, so I'm not going to promise anything, but, you know, we've done certain things with, like the CFMS, where we've tried to be creative and co-invest in you know, roles, appointments, or activities. And, you know, the worst thing that can happen is that we say no. We rarely do. Get in touch with us and ask, and then we'll start that, you know, that dialogue and see how we can help and work together. Thank you, Ian.
Thanks, Ben. Janice.
I'd like to make a sort of a few closing remarks. So that was a really great summary from Ben. I just want to bring it back round to the sustainability agenda, and I think one of the schools of thought in our area, which is sensing and understanding materials and structural performance and so on, is kind of, you know, what happens through life. And, you know, the terminology has been for several years now, cradle to grave. Well, I think what we need to cancel that thinking, and we need to call it cradle to cradle, because once we've used this component, what else can we use it for? And that's particularly important for these large composite structures that are around in marine and wind blades and aircraft and so on. And how can we use our technologies to rebirth these materials that would otherwise not be disposed of very well? And the hyperdiff project is a prime example of how we're working at University of Bristol to actually reclaim this material. And I think it's a start of a reset in our thinking, which I've started to call cradle to cradle.
Thank you, Janice. That's a really good point to end on. So that our time is up, I'm afraid. So I'd like to thank the panel very much for their contributions, and I hope you found that insightful in terms of a brief expose of activities that are going on and directions of travel. We've covered a lot of ground, sustainability, the effect of digitalization on activities, and also in how we have impact and how we see that knowledge transfer and our role within skills and training development, as well as that sort of broader education piece. So I do hope that's given a sort of an indication of some of the things we can work with partners on. And as Ben said, we are open for discussion with anyone who wants to talk what ideas we have. We are an ideas organisation by our very nature, and we'd be glad to have conversations with anyone who wants to discuss where we can work alongside you. That is our role and remit, and we very much want to do that. So I'd like to thank you all for your time as well. I appreciate, time is always precious, and taking some time out from your busy schedules to listen in is very much appreciated. So thank you very much. This will be recorded, or has been recorded, and all of the sessions will be made available subsequently via our website. So there will be opportunities if you have colleagues or others who you think might benefit from listening in. Again, we will be able to offer that opportunity for people to come back and listen again. So thank you very much. And thank you to everyone. Thanks to the panel again. So goodbye for now from us at Bristol.
All right, thank you.
Bye, and thanks for attending, everyone.
Bye-bye.